Welcome to this presentation on JVM Architecture, the backbone of how Java programs run efficiently on different platforms. The Java Virtual Machine, or JVM, is responsible for executing Java bytecode, which abstracts the hardware layer from the developer. Essentially, it allows your Java code to run on any machine without modification. Let's break down the key components of this powerful system. First up is the ClassLoader. This component is responsible for loading .class files into the JVM, converting Java bytecode into a runtime structure that the JVM can understand and execute. There are three types of class loaders: Bootstrap class loader, which loads core Java classes such as java.lang and java.util; extension class loader, which loads classes from extensions in the jre-libx directory; and application class loader, which loads your application's code specified by the user from the class path. One of the most critical components of the JVM is the garbage collector. Its primary task is to automatically reclaim memory used by objects that are no longer referenced by the program. This ensures that your application doesn't run out of memory over time. Next is the execution engine, which is responsible for interpreting the bytecode and executing the program. The execution engine consists of an interpreter, which executes the bytecode line by line, and the just-in-time compiler, or JIT, which converts frequently executed bytecode into native machine code, significantly improving performance after the code has been interpreted several times. Now let's move on to the runtime data areas, the regions in memory where the JVM stores data like variables, objects, and methods. These data areas include the method area, where class-level data such as fields, methods, and the constant pool are stored; the heap, where Java objects and instance variables are allocated at runtime; the stack, which is private to each thread and stores frames, containing local variables and references; the program counter, which points to the current instruction being executed; and the native method stack, used for native method calls, typically written in C or C++. Lastly, we have the native interface. The Java Native Interface, or JNI, provides the framework that allows Java code to interact with native code written in other languages such as C or C++. This interaction is crucial for integrating Java applications with native libraries. To recap, the JVM is composed of several key components: the class loader, runtime data areas, execution engine, garbage collector, and native interface. These components work together to ensure that your Java code runs smoothly across different platforms. Thank you for attending this presentation on JVM Architecture.